Hello and welcome back to Mr. Pog Talks About Math. All right, so today we're going to talk about solving equations and inequalities when we have to do some distribution in them. All right, so we're going to be using the distributive property, which is something we've learned about so far. We're also going to be combining some like terms. All right, so sometimes, I'm going to start off a little bit easy, kind of review what we know about how to solve equations first off before we jump really far in. So if I wanted to solve an equation like this, 4x plus 7 equals 47. Right? My first step is that I need to move all of my constants away from where my variables are. So in this case, that means that plus 7 has got to go, right? We got to move that over to the right-hand side away from the 4x. So to do that, remember that what we do is we use inverse operations, right? So instead of having plus 7 there, we want to cancel that out, so we're going to do the opposite. We're going to subtract 7. Right, what we do to one side of an equation or inequality, we have to do the exact same thing to the other side, right? So I'm going to subtract 7 over there. So when we do that, we get 4x. Those 7s are gone. And then on the other side, 47 minus 7 is just 40. All right, from here, what we want to do is we need to get rid of our coefficient. So in this case, that's 4x, right? So that 4 is what we need to ditch. Don't forget that 4x is really 4 times x. There's really like some little hidden multiplication going on there. So to undo that multiplication, we're going to do the opposite, which is to divide. So I'm going to divide by 4. Right? That'll get rid of it. And again, I need to do the same exact thing on the other side. Right? So if we divide everything by 4, those are gone, right? Which is what we were hoping for. We get just an x left over. And on the other side, 40 divided by 4 is 10. Boom, done. That's it. Right? 2 steps, and then we're good. We also have talked about 2-step inequalities already. So this is going to be kind of the same thing, right? The only difference is that we've got this symbol in the middle. We've got a greater than or equal to sign. So right off the bat, that we're going to treat it like an equal sign up until we either multiply or divide, right? And then we'll talk about what that step is. Right? So we got 7x minus 5. Well, I don't like the looks of that minus 5. I'm going to do the opposite to move that on over. All right, so when we do that, we get 7x. Those 5s are gone. Keep our symbol, right? Don't forget that we're working with a greater than or equal to sign. Don't put an equal sign by accident. Then 37 plus 5 will give us 42 over there. Okay, so here, again, 7x is really 7 times x. We're going to divide by 7 to get rid of that coefficient. It's going to also divide 7 on the other side. So the 7s are gone. You're left with just x. 42 divided by 7 is 6. And then this is where the inequality sign, we got to be a little bit careful of. So when we're working with inequalities, if you multiply or divide by a negative number, then you have to flip it to face the other way, right? So again, when you multiply or divide by a negative, flip the sign. In this case, we divided by a positive 7. Right? So that means that we're actually okay to just leave the symbol the same. Right? So that's pretty nice, right? We didn't really have to worry about it here. Right? So again, we basically treated that like an equal sign until we either multiplied or divided. And we just had to check and see, all right, was it a negative? If it was, we got stuff to do. Yeah, let's try another one out. This inequality, again, same deal. We have negative 3x plus 6. That 6 has got to go. We want to get that away from where the variables are. So instead of plus 6, let's subtract 6 from both sides. So you get negative 3x is less than 15 on that side. Okay. After that, again, negative 3 is negative 3 times x. We got to undo that times, so we're going to divide on both sides. All right. When we do that, those negative 3's are gone. We have just x. 15 divided by negative 3 is negative 5. And then this is what I was talking about on the last one, right? Now that we've divided, we got to be real careful. We divided by negative 3. Because that was negative, we need to now flip our sign to face the other direction, right? If you're wondering why, right, please go back to the 1- and 2-step inequalities. We took a look, maybe about a quarter or a third of the way through about, why do we have to flip it? It's because everything gets all topsy-turvy when you multiply or divide by negatives, which means that we need to flip our inequality sign, okay? So the real meat and potatoes of what we're doing today is right here, right? These are our steps for solving equations and inequalities where we have to distribute first, right? So if you need to pause and write these down after I'm done talking about them, that's fine. So our first thing is that we're going to distribute in any parentheses we have, right? That's the whole thing, distribution. After that, we may have some like terms that we need to combine, right? So we'll take a look at that again. After that, these last couple steps are ones that we've done already, right? We need to either add or subtract to move all the constants over to one side, right, away from the variables. We were just doing that. Then we either need to multiply or divide to clear any coefficient we have, right? Get that variable entirely by itself. And then that last step that we just talked about, for inequalities, if you multiply it or divide it by a negative number, you got to flip your inequality sign, right? And that's just for inequalities, right? If you have an equal sign, doesn't matter, right? I suppose you could flip your equal sign, but if you flip your equal sign, right, you're going from something like this and you flip it the other way, it still looks the same, so it really doesn't matter either way, okay? So let's take a look here. We're going to solve this one. First things first is that I got to think through those steps, right? Distribute into the parentheses. Okay, so I have this 2. I'm going to need to distribute it into these parentheses here, right? Don't do what I see a lot of people make a mistake on. They're like, ooh, we're distributing. Ooh, there's a 2. Let's just distribute it out all the way, right? Don't do that, right? You only distribute into the parentheses that it's next to, right? So when we do that, 2 times x, we're just going to put that as 2x. Right? There's no other way that I can smush them together, right? It's 2 times x. There we go. 2 times x. 2 times 3, however, is going to give us 6. And then over on the other side, it equals 8. Right? So nothing super fancy. From here on out, it's just one of the 2-step equations that we already know how to solve. Right? So first things first is I'm going to move that 6 over to the other side, right, by subtracting it from both sides. So we'll end up with 2x equals 2. After that, I need to get rid of that 2 that's in front of the x. So I'm going to divide by 2, just like we have been doing. So I'm going to get x equals 1. Well, bam, that's it. Right, hopefully that doesn't seem so bad. Let's take a look at another one. What I'd like you to do, pause here, try at least the first step of this one on your own, right? Try doing the distribution. Right? If you want to keep on going and see if you get the whole thing right, be my guest. Right? So what we're going to do is we're going to distribute that 5 into these parentheses. So that first part, 5 times x, is just 5x. 5 times 2 is going to give us 10. And then we bring along that minus 35 on the other side. Okay. Again, after that, we're moving our constants away from where the variables are, right? So 5x doesn't need that plus 10. We're going to subtract 10 to get rid of it. And so we're going to get 5x equals, and then on the other side, negative 35 minus 10 more will bring us down to negative 45. Right? Again, a reminder, if you're feeling a little iffy about negatives at any point and you want to double check yourself, a calculator is always fine to use. Right? So after that, we have 5x. That's 5 times x over on the left. I'm going to get rid of that 5, so I'm going to divide by 5 on each side. When I do that, so you cancel out, right? Don't have any 5s anymore over there. We just have x, and then on the other side, negative 45 divided by 5 is negative 9. Okay, and then we're done, right? X is equal to negative 9. There we go. Oh dear, right? This one looks a little gross. There's lots of parentheses here. So again, we're going to distribute into the parentheses first. That's our first step. So what that's going to look like is I'm going to distribute this 2 into this set of parentheses that it's next to. Again, a mistake that I see people doing is that they're like, oh yeah, then we distribute into these parentheses too, right? We just do all the way across. No, don't do that, right? What we distribute into the other set of parentheses is basically this negative sign, right? That's what's in front of those parentheses, right? Something we, can talk about, or hopefully have talked about in the past, is that there's a little invisible 1 hanging out there. Right, so it's kind of like we have negative 1 multiplying those in there. Right, so don't make the mistake of putting that 2 out to each and every thing. It only goes to the parentheses that it's next to. Right, so when we're distributing over in the red, 2 times 3x, well, 2 times 3 gives us 6, and that x is along for the ride. 2 times 4 is going to give us plus 8. Right, over in the blue, we have negative 1 times 9x. Well, negative 1 times 9 is negative 9, and again, that x comes along with it. After that, we have negative 1 times negative 7. That is positive 7. So plus. And over on the other side, we get 6. Okay, so from here, right, this is the first one where we actually have to combine some like terms. Right, so when we're combining like terms, right, remember that they have to have the same exact variables with the same exact exponents on those variables. Right? So in this case, if I'm looking at 6x, I can smush that together with this negative 9x. Right? Something you might have just noticed right now is that I grabbed the symbol that's in front of that 9. Right? It was a negative sign. That is negative 9x as we're going to handle it. I can also smush together the 8 and the 7. Right? Those are like terms. You might be thinking to yourself like, well, Mr. Pog, 6 is also going to work together with 8 and 7, right? But what we want to do is we cannot combine like terms across the equal sign. There's like a barrier there. You can only combine like terms if they're on the same side like this. Okay? We can move things across, but that's where we have to do the inverse operations, right? We have to do the opposite to move them across the equal sign. Okay, so we've got these like terms. Let's smush them together. In the yellow, 6x minus 9x is going to bring me down to negative 3 x's. Right? So, again, I'm not changing any sort of exponent. I'm just changing how many x's I have. Right? So 6 minus 9 brings us to negative 3. For the numbers, in green, right, 8 plus 7 is going to give us plus 15. Right? And again, nothing too fancy there, right? We've been adding and subtracting numbers for years. Okay, so now we have negative 3x plus 15 equals 6. Okay, after that, again, I just need to go through my normal steps. I'm going to move that 15 over to the other side by subtracting it. Okay, when I do that, I have negative 3x. I got an equal sign. And then 6 minus 15 is going to bring me down to negative 9. Again, I'm going to say the same thing over. If you're feeling a little iffy about negatives, right, it never hurts to use a calculator. It's okay. After that, we have negative 3x, right? I want to get rid of that negative 3, but it's multiplying x, so we're going to have to divide there. All right, so I'm going to divide everything by negative 3. We'll get just x left over. And then negative 9 divided by negative 3 is going to give us a positive 3 for our answer. All right. So I know that these are not like super thrilling. They do have a lot of steps, right? But I'm hoping that if you take it one step at a time, it really doesn't seem that difficult. Right? What I'd like you to do is try this one on your own and then unpause when you think you got it, right? It's pretty similar to the last one we just did. All right, so hopefully you did that. I'm going to run through it. I'm going to distribute into this first set of parentheses. 3 times 4 gives us 12, and the x comes along for the ride. 3 times 3 is 9. For the second set of parentheses, right, we've got that little invisible 1 hanging out again. And we're going to distribute that into that set of parentheses. So negative 14x is what we'll get off the first one there. And then plus 11. Right, at the end we've got 8. For like terms, this 12x can smush together with this negative 14x. This 9 can smush together with that 11. Right, again, we're looking for things that have the same variables with the same exponents on those variables, right? Which in this case is that we don't have any exponents. So in the yellow, 12x's minus 14x's is going to bring me down to negative 2x's, right? Again, we're not changing, anything about the x. We're just changing the coefficient. It's talking about how many of them we have. In the green, we got 9 plus 11 is going to give us 20. And again, we've been adding numbers for years. Nothing too fancy going on there. Okay, now we have a 2-step equation to do. We're going to move that 20 away from where the variable is. So we're going to subtract it to move that to the other side. All right, 8 minus 20 is going to bring us down to negative 12. Last but not least, we have to get rid of that negative 2 that's multiplying x. So I'm going to do the opposite and divide by negative 2. Okay, so we're going to get x, and then on the other side we've got 6. And then we're good. All right, so if you tried that all on your own and you got 6, then bravo. It's not an easy thing to do, right? But the best way to get better is to practice, right? Just like with anything. Let's take a look at some inequalities, right? Same thing to start, right? I'm going to take whatever's in front of any parentheses and distribute it into those parentheses. All right, so that 6 is going to multiply into there. Again, don't make the mistake that I see people do where they're like, oh yeah, and then we'll distribute it over here too, right? That 73 is not in the parentheses, so we don't distribute to it, right? So -6 times -4 is -24, and that x just comes along with us. Oh man, 6 times -23, right? That's going to be -138. Right? And again, use a calculator if you're not sure about it. After that, I'm just going to bring everything else down. -73 less than 77. Okay? And again, this is an inequality. We got to be a little careful, right? If we ever multiply or divide both sides by a negative, you know what we got to do. We got to flip that sign. So from here, we have some like terms that we can combine, right? I have this -138 and this -73 that are on the same side. I can smush those together. Right? That -24x, unfortunately, doesn't have a buddy. We just leave it as -24x. Right, so -138 minus 73 more is going to bring us down to -211. Right, and again, we're bringing everything else along the same way. Right, so that -211 is what we got from combining. After that, again, we've got two-step inequality in this case to solve. So what I'm going to do is I'm going to move that 211 away from where the variables are. I'm going to do the opposite, which means I'm going to add it over there. All right, so -24x is less than, and on the other side, 77 plus 211 is going to be 288. All right, sweet. One step left, and by one I mean 1.5, kind of. Right, we have -24 times x over on the left. Let's get rid of that. So we're going to divide by -24. All right. Some of you might already notice what the little half extra step is. All right, so over on the left, those -24s are gone. We just have x. Over on the right-hand side, 288 divided by -24 is -12. All right. So the last little thing that we have to be careful of is we have an inequality. We just divided. And to boot, we divided by a negative number. So that means that we have to flip our sign to face the other direction. Right? If you forget to flip your sign, your answer is going to be talking about the entire wrong half of all the numbers in the world. Right? So be careful. Make sure you flip it if you're supposed to. Okay? If you're feeling up to it, right, pause here, try this one out, see what you get. Right? If you're not feeling as confident about it, just follow along with me. All right? So same kind of idea, right, as what we were doing in the past. I'm going to distribute into these parentheses based on whatever is in front of them. Right? So -4 times x over in the red is just 4x. 4 times 3 is +12, so plus 12. Right? In the blue, we have -8 times 2x. Right? So -8 times 2 is -16, and the x comes along with us. -8 times 10 is going to give us -80. Right? And again, bringing down that less than sign and that -20 at the end. Okay. Now we've got some like terms to combine, just like before. We've got a 4x and a -16x. We've also got a 12 that can smush together with that -80. Okay, so with the yellow first, let's take care of those x's. If I had 4 x's and I'm taking away 16 x's, I'm going to end up with -12 x's left over. All right, so again, not changing the exponent on it, just changing how many we have. In the green, 12 minus 80 is going to bring me down to -68. Right? Again, nothing fancy going on there, just some numbers. Right? After that, bring down our less than sign and then -20 on the other side. So again, 2 steps left, basically. By 2, I mean 2.5. So we need to move that 68 away from the variables. We're going to do the opposite. So we're going to add it to both sides. All right, so we've got -12x. We've got a less than sign, and then -20 plus 68 is going to bring us up to +48. Okay. Last but not least, that's -12 times x. I want to undo that, so I'm going to divide by -12. All right, again, doing the same thing on both sides. We get x, the other side we get -4, and we divided by a -12, so I got to flip my sign to face the other way. Right? Be careful that you make sure you do that. All right. 2 problems left, and then I will stop talking to you. Oh my gosh, I bet you're so excited. So this one, oh man, this looks kind of gross. 594 is greater than -2 times x minus 9 in parentheses plus 3 times 7 minus 8x in parentheses, and then minus 17. Holy moly. All right, let's talk it through. It's not going to be as bad as it looks. We're going to do the same steps. We're going to start by distributing into those parentheses. Right? Again, taking only the stuff in the parentheses when we're multiplying. That 17 is not in parentheses, so we leave it alone. All right, so 594 is going to stay over there. We're going to have that greater than sign. And then in the red, -2 times x is -2x. -2 times -9 is plus 18, right? It's positive 18. In the blue, 3 times 7 is going to give us 21. And then 3 times -8x is going to give us -24x. Okay. Last but not least, we tack on that minus 17 at the end so we don't forget about it. Okay. So we've done our distribution. Our next step is to combine any like terms we have. Right? So I have got -2x and -24x. Those are like terms. As for numbers, I've got 18, 21, and -17 that can all smush together. All right, so what I'm going to do from here is I'm just going to combine the like terms, right? I'm not going to even worry about 594 yet. So 594 is greater than, right? In the yellow, -2x's, take away 24 more x's, brings us down to -26x's, right? In the green, we've got 18 plus 21 minus 17, right? So again, use a calculator, right? So we've got 18 plus 21 minus 17, right? 22, not too bad. All right, so plus 22 there. Right, if you're somebody that really likes to challenge yourself, you can do it in your head as well. Right, I would take care of the addition first and then subtract 17 from what you get. Right, but if you want to use a calculator, it comes out the same anyway. And so from here, right, it looks much better than what we started with, right? 594 is still not a nice number, but it looks much better. So our variables are over on the right-hand side, right? It's -26x. So what I want to do is I need to move this 22 away from it. All right, get that away to the other side. So 594 minus 22 is going to give us 572. Bring our sign down, and then we still have -26x over there. Okay. Last step and a half, right? This is -26 times x. I want to get rid of that, so I'm going to divide by -26. All right, when I do that, 572 divided by -26 is -22. Over on the other side, we are just going to have x, right? And then we divided by a negative number, so we got to flip our sign to face the other way. All right, so with this last step, right, this is our answer. -22 is less than x. I know that there are a lot of people that really like to have their x on the left-hand side when they write their answer. What I'm going to tell you is that if you wanted to write your x on that side and your -22 over here, that's perfectly fine, right? But please make sure that your symbol is still opening in the same direction, right? So my symbol is opening towards x. That means that when I flip it, it should still be opening towards x, right? Either one of these is okay, right? If you're feeling a little iffy, like, oh man, I don't want to have to worry about like, oh, did I write this second way right? You can just leave it with the x on the right-hand side. That's still the same answer, right? Either one is fine. Right? One word problem, and then we are good to go. An estate worth $260,000 is to be split amongst the owners, 2 grandchildren, 3 grandchildren, and a charity. Each child receives the same amount. Each grandchild receives half of the amount each child received. If the charity receives $15,000, we want to figure out how much money will each child and grandchild have. All right, so again, what I would suggest on word problems and what we're going to do here is I'm just going to read through it again. And I'm going to highlight important pieces of information. So an estate is worth $260,000. it's going to be split amongst the owner's 2 children, 3 grandchildren, and a charity, right? So it's getting split sort of like 3 different ways, kind of. Each child receives the same amount. Each grandchild receives half of the amount each child received, right? The charity is getting $15,000, and we want to figure out how much money will each child and grandchild receive, all right? So you can see that, there's a lot that's highlighted here. There's a lot of important pieces of information. All right, so let's break it down. We've got $260,000, and we're splitting it up. All right, so 2 children, 3 grandchildren, and a charity. The important part here is that each child receives the same amount. Right? We're trying to figure out how much money each child and grandchild will receive. So what we need to do is we need to set ourselves up with a variable. So what I'm going to do is I'm going to say that our variable is just x. X is going to be the money that's going to each child, right? So it's how much each child is receiving, right? We also have the grandchildren. Each grandchild receives half of the amount each child received. So if I needed to represent half of that amount, x, I would just write it as 1/2 x. Right? So that's the money for each grandchild. Right? We also know that the charity is getting $15,000, right? So let's kind of put all this together. So there are 2 children, so that's x plus another x, right? We don't know what that amount is yet, but we know that we're having 2 of them. There are 3 grandchildren, so we're going to add on a 1/2 x for each one. And then the charity, which is getting $15,000. All right. Altogether, that's going to account for the entirety of that $260,000 of money. All right, so I'm going to put it $260,000 on the other side. Okay. So this looks a little bit gross, I will admit. But we're going to take one step, and then it's going to look much better than what we have right now. So what I'm going to do is I'm going to combine like terms. I've got x plus another x plus 1/2 an x plus another 1/2 an x plus another 1/2 an x, right? So all of those x's can be smushed together. If I think about how many I have, right, I have 1, 2, 2.5, up to 3, and then 3.5. So altogether, I have 3.5 x's, right? I've also got that $15,000, and altogether it equals $260,000. Right? So right now, this already looks a little bit better than what we started with, right? So 3.5x plus 15,000 equals 260,000. Same idea as always, right? We need to move this 15,000 away from where the variables are. All right, so let's take care of that by subtracting it. We're going to get 3.5x is equal to $245,000 over on the other side now. All right, and then this one's going to be a little gross, right? So where you have 3.5 times x, let's undo that. Let's divide by 3.5. All right, so when we divide by 3.5 on both sides, we're going to get just x. It's going to have an equal sign. And then $245,000 divided by 3.5 is $70,000. All right, so now that we know what x is, we can actually finish the problem, right? We want to figure out how much money each child and grandchild will receive. All right, so each child is going to get $70,000, right? That's what x equals. If we wanted to figure out how much each grandchild is getting, we would split it in half, right? If you split 70,000 in half, each grandchild is getting $35,000. Pretty sweet. All right. So if any of this is a little bit tricky, that's okay. We're going to practice it when I see you during class, so don't worry about those practice problems at the end. Be sure to check on Google Classroom for any additional stuff, and be sure to ask questions if you're unsure about how to do something, right? I'm here to help, right? And I'll see you next time.